Agent reliability benchmarks just expose the gap between occasional success and consistent, stateful execution in real business workflows. This is Models and Agents, episode 148. Thinkingbox introduces a sandbox and 507 workflow benchmark across retail, insurance, and IT support domains that measures end-to-end state transitions rather than isolated tool calls. Several arXiv papers released today examine attention allocation, KV cache reuse, and multi-agent hypothesis generation. Builders should watch how these evaluation and efficiency techniques affect long-running agent deployments this week. Microsoft released Thinkingbox, a sandbox and benchmark for agents operating in stateful business workflows. The benchmark contains 507 policy-conditioned workflows spanning retail, hospitality, auto insurance, neobank IT, and consulting support. Each workflow is evaluated by executable checks on terminal backend state rather than surface-level tool calls or responses. The strongest model reached 65.36% pass at 1, but only 25.25% pass to the power of 20. This shows that many failures produce clean terminations and valid state changes, yet still miss required outcomes. This directly tests multi-turn information gathering, policy adherence, and persistent state transitions that current agent benchmarks largely ignore. Teams building production agents should examine the released repository to see where their current evaluation harnesses fall short on these dimensions. A paper titled Asymmetric Attention Heads introduces structured headwise context allocation for transformer attention. The method assigns different causal context windows to individual attention heads or groups instead of giving every head the full span. In 4,096 token experiments, several variants achieved lower validation loss than standard full attention while preserving the flat multi-head output interface. The approach groups heads by feature statistics and uses hierarchical allocation with attention coverage ratio reported as a diagnostic. Builders working on long context models should test whether per-head window assignment improves quality at fixed compute budgets. Another paper titled Compliance, Capability, and Conflict benchmarks multimodal large language models under system messages. vSysBench evaluates 16 multimodal large language models on system message constraints across 5 main categories and 22 subcategories. It scores both constraint compliance and answer correctness via joint satisfaction rate. Imposing system messages substantially reduced base task accuracy for all models. Open weight models showed sharp compliance drops under user conflict while top proprietary models remained stable. Vision-grounded constraints proved hardest across every model tested. Developers deploying multimodal large language models with strict system prompts should add this benchmark to their evaluation suite. Flash Prefill v2 adds a mean correction term to suppress approximation error at high sparsity. It redesigns the sparse operator with pack GQA and warp specialization, and supports paged KV cache plus continuous batching. On NVIDIA H20 GPUs, it delivered up to 47.26 times speedup over Flash Attention 2 at 128K context under FP8. It also achieved 30.49 times against an FA3/4 aligned dense baseline. The implementation is positioned for integration into frameworks such as SGLang. Teams serving long context workloads should benchmark the FP8 path on their hardware. SWE Bench Science introduces a new benchmark with 119 tasks from 98 GitHub repositories across 20 scientific domains. Claude Code with Opus 5 Max achieved below 50% pass at 1. 4 recurring failure modes were identified: deficits in scientific knowledge, misguided exploration, incomplete repair coverage, and failures to generalize beyond observed cases. An ablation showed that well-grounded scientific guidance can improve both performance and token efficiency, while poorly aligned guidance induces anchoring. Scientific software teams should incorporate the benchmark when testing coding agents. Personal Bench evaluates inference time personalization across 50 authors and 1,000 generations using LUAR, LLM as judge, and stylometrics. All tested methods produced author-differentiated output with LUAR AUC of 0.918. Yet outputs remain below the human cross-author similarity floor, with the model's own fingerprint dominating. Developers building personalized writing tools should add this benchmark to quantify how close outputs actually come to target authors. Recache caches resource representations independently using resource-wise attention that removes cross-resource interactions and produces composition-invariant KV blocks. On a benchmark assembled from 7 public tool-use datasets, it matched dense invocation performance at 82.3% versus 82.4% in F1. It delivered a 3.655 times time to first token speedup and reduced allocated KV tensor memory by 92.43%. The framework also accelerates attention by 1.423 times and supports resource disjoint test cases. Agent developers facing repeated tool schema encoding should evaluate the released implementation. A post on r/machine learning introduces DriftGuard, an open-source detector that measures relevance and self-drift against an agent's own history using bag of words by default. It fires only after the breach holds across 25 consecutive windows. It achieved 0 false alarms on 600-step healthy runs while detecting derailment at step 228 in a 400-step trace. The package has no dependencies, runs offline on Python 3.10+, and is available at the linked GitHub repository. Teams running long agent loops should integrate the detector to halt drifting executions early. Analysts warn that agentic AI is lowering barriers for organized crime groups running large-scale scams across Asia. The report highlights how autonomous agents can handle multi-step social engineering campaigns at scale with reduced human oversight. Security teams monitoring agent deployments should review current guardrail coverage against these emerging misuse patterns. Remember, we covered agent reliability yesterday, and today's releases move that forward by adding concrete state transition metrics and drift detection tools that directly target the open question of long-horizon consistency. SynFlow converts linguistic observations into period-specific distributions and applies a shared workflow across dependency co-occurrences, morphological features, constructional patterns, and frame semantics. It supports multiple distance measures, value-level decomposition, statistical testing, and incremental clustering. A case study on the German adjective viral demonstrates how a single semantic shift appears across syntactic, lexical, and morphological dimensions. Researchers tracking lexical change should test the open-source toolkit on their corpora. A method uses a large language model to automatically generate personas with added communication-style personality traits. This increases utterance variation in user simulators. Experiments showed the approach produces greater behavioral diversity than manually crafted personas while reducing labor. Dialogue system developers should adopt the technique when scaling test coverage beyond small handwritten persona sets. Work on forking fast shows that uncertainty dynamics in large language model reasoning chains converge to stable patterns once enough rollouts are collected. This allows a statistical smoothing model to approximate high sample results from lower sample data. The approach reduces the computational cost of resampling-based uncertainty analysis. Teams analyzing reasoning chain variability should examine the smoothing approach to lower their sampling budget. Okay, let's pop the hood on Flash Prefill v2. Everyone talks about sparse attention as if it is simply turning off some tokens. In practice, it is a sequence of decisions about pattern discovery, error correction, memory layout, and integration with existing inference stacks. Flash Prefill v2 first discovers a sparse pattern on the fly. Then it applies a mean correction term that keeps approximation error manageable even at extreme sparsity levels. The operator is then rewritten with pack GQA memory access, warp specialization, and ping-pong pipelining so it aligns with Flash Attention 3/4 kernels and supports FP8. These changes deliver 30 times plus speedups at 128K context on H20 GPUs, while preserving nearly identical task performance. The practical engineering takeaway is that teams should first validate the mean correction term on their workload before investing in custom kernel integration. Without it, quality degrades faster than the latency savings justify. Run Thinkingbox workflows on your current agent setup to measure pass to the power of 20 rather than pass at 1, and identify where state transition failures occur. Test recache on repeated tool schema workloads to quantify KV cache memory reduction and time to first token gains. Add vSysBench to multimodal evaluation pipelines to check how system message constraints affect both compliance and task accuracy. Experiment with per-head context allocation from the Asymmetric Attention Heads paper on long context fine-tuning runs. Integrate DriftGuard into existing agent loops to halt executions once relevance or self-drift thresholds are breached. More agent benchmarks that evaluate persistent state changes rather than isolated tool calls are expected in the coming weeks. Additional block sparse and KV cache reuse techniques for long context serving will likely appear as inference frameworks adopt Flash prefill style operators. Further work on multi-agent hypothesis generation and evaluation frameworks is anticipated following today's arXiv releases. Before we go, the next round of agent reliability results will test whether the new state transition metrics hold up on even larger workflow sets. That's models and agents for today. If you found this useful, share it with someone who's trying to keep up with all these changes, and subscribe so you don't miss tomorrow's update. The AI world moves fast. We'll help you keep up. See you tomorrow. And if you'd rather watch than listen, find us on YouTube at Nera Network. Links in the show notes. Quick tip from the network. Try modern investing techniques next. Modern strategies for Canadian and US investors. Every Nera Network show is free at neranetwork.com. Following the long arcs, story trackers on neranetwork.com follow major programs across episodes: Tesla, SpaceX, AI, space science, and more. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.